Alright, we're gonna talk about domain and range. So let's start by considering a machine. We're gonna start really simple and build an understanding for it. So this is, if you absolutely don't know what's going on, this is a video for you. Hopefully, let me know if it did change anything or if you're still in the same boat that you were in. Um, Obviously, it would be constructive feedback if you could tell me if it didn't help. Now, we've got a machine, which is a function. That's a function or a graph. Well, this is where it started in grade 7, where you did a block and then you put a number and you got a number out, and you put a different number and you got a different number out. Well, that's how functions started, and that's how we hoped you understood it as. So there's an input that goes in and then there's an output that comes out, right? Now, if I take a bunch of inputs and get a bunch of outputs, I can draw this table. Now, that's not really what we're here for. What we're here for is to understand domain and range. Now, how does this relate to domain and range? We have two questions that you want to ask. What values are allowed to go into the machine? So, what can I put in for x? What can I put? That's the question we're asking. That question, the answer in this case, well, is anything. You can put anything in this machine. I can put any number, any real number. I can put any real number, because no matter what I put, it's gonna give me an answer. If I put 3, if I put 700, if I put a million, if I put negative trillion, if I put a quarter, if I put 0.000000007, it's gonna give me an answer. No matter what I put for x, it's gonna give me an answer. Any real number, whether rational or irrational, is going to give me an answer. Okay, so that's first. What values are allowed to go into the machine? The second thing is, what values can come out of the machine? So in this case, again, it's everything. If I put if I can change the input and get different outputs, I can get any number, right? So if I put 1, I get 5. If I put a half, I'll probably get maybe what, 4, I think. Yeah, I'll get 4. If I put 1.5, I'll get 6. So I can get even those numbers in between. 3, 5, 7. I can get those numbers in between them. I can get basically any number in the output. So again, I can get every real number. Now the question we asked, what values go into the machine? That's the domain. And what comes out of the machine? That's the range. This function is a straight line function. The domain again is the x values, because you put x values into the machine, and the range is y because you put y values into the machine. So from this we understand that the domain of a straight line function is x is the element of real numbers and y is the element of real numbers. All right, that's the concept we have here. But now the way we understand this is, it's easier to understand it from a picture, from a diagram. And we ask ourselves, along with these two questions, for domain, we ask ourselves, how wide is the graph? And for range, we ask, how tall is the graph? And then we answer it based on that. So let's look at this now. So we'll start with this one, the x values. So let's start with this one, the straight line graph. The domain for a straight line graph obviously is your x value. So what x values can go into a straight line graph, or how wide is this graph? So this graph is infinitely wide. It goes from negative infinity right until infinity. Now, how do you write that as a domain answer? So there's different ways to write it. The way I've told you to write something like that is x is element of real numbers. You could have even represented it as x is the element of negative infinity until infinity. That means it's every number between negative infinity to infinity. And then how tall is the graph for range? So for your range now, again, you can say y is the element of real numbers, or y is an element from negative infinity to infinity. So how high and low your graph is. Let's try this graph. The parabola that we're looking at. How wide is the graph? Alright, you've thought about it. So how wide? It's infinitely wide. So it can go x element of real numbers. How tall is parabola? Alright. So clearly it's not infinitely tall. It goes down infinitely. How high does it go? Basically, if you have to picture a number line and 2 was here, basically it touches 2 and goes down. So can we not say that y is less than equal to 2? That's the range. That is perfectly the range. What about this hyperbola now? How wide is it? So you would say it's infinitely wide, and that would be correct. X is an element of real numbers, but there's a slight problem. It doesn't exist here at the asymptote. So we can just to omit that from all the real numbers. There's just one number it doesn't exist for, and that's 2. So we say, okay, everything except 2. Right? And how tall is it? Y element of real numbers. Y not equal to 1 because it's up and down except here at 1. What about this? How wide is it? Infinitely wide. So x element of real numbers. And how tall? So it doesn't go above 1. It's below 1 and infinitely below 1. So y is less than 1. If you pictured your number line with 1 over here, you draw a circle and draw downwards, but not color it in because that's an asymptote. And that's how you'd represent your domain and range.